Hello class, today we're going over lesson 1.7 and this just goes over more properties of integer exponents. So yesterday we learned about we learned about four properties. We learned about the power of products, the product of powers, the power of powers, and the quotient of powers property. So remember, those tell us that, for example, if we have an a to the third times a to the fifth, and we could simplify this by doing a to the 3 plus 5 or a to the eighth. If I were to have 2 to the third times, let's say 4 to the third, then we could simplify this by multiplying together our bases. So we can do a 2 times 4 to the third or 8 to the third. The power of powers property tells us that when we are raising a power to another power, let's do something different. Let's do 3. What we can do is we can multiply the exponents together. So this would become 2 to the 2 times 3, or 2 to the 6th. And then lastly, the quotient of powers, or when we are dividing two integers with exponents. Let's do variables here. Say we got x to the 5th divided by x to the 3rd. What we can do is we can either stack these on top of each other, or we could go straight forward to the subtracting exponents where we have x to the 5 minus 3, which become x squared. All right, so those were the four we learned yesterday. Now let's go over our two new ones today. So our first one is the zero exponent property, and I'm sure this sounds pretty familiar to all of you. So the zero exponent property tells us that whenever you raise a base to the power of 0, the result will be 1. So the example I gave you here was 3 to the 0 is equal to 1. And this works for anything. We could raise any number we want to the power of 0, and we would get back 1. So if I do 0.25 to the power of 0, I get 1. If I do, let's say, 1,000,000 to the power of 0, that's going to return us back to a 1 as well. So anything you raise to the power of 0, you will get 1. Okay, the next thing we have is the negative exponent property. So the negative exponent property tells us that any base raised to a negative number will become a fraction with the same base and exponent, except now it's in the denominator. So for example, if we're thinking about this algebraically, a to the negative n would become 1 over a to the n. Or for example, if we're raising something like an integer to a negative power, 8 to the negative third will become 1 over 8 to the third. And we could say that with anything, right? Let's say I want to take 25 to the negative 2. Then we could make this into 1 over 25 to the second. So whenever you see whenever you see a negative exponent, what you have to do is you have to turn it into a fraction where your exponential base, your base and its exponent will become the new denominator, except now your exponent will be positive. Okay, so for our key concept today, you can use these additional properties when simplifying or generating equivalent expressions with exponents. And I just restated our properties for you today. Again, the zero exponent property tells us that any base raised to 0 will be equal to 1. And the negative exponent property tells us that whenever you're raising your base to a negative exponent, it simply becomes a fraction with your base and your new positive exponent in the denominator. Okay, so first thing we want to do here, we want to write 7 to the negative 6 using a positive exponent. Well, this right here should invoke some memories of our negative exponent property because we have a negative exponent. So the negative exponent property tells us that whenever we are raising a base to a negative number, we can turn it into a fraction where the 1 is our numerator and our denominator will be the base to its positive exponent. And that's all we have to do here because it just wanted us to change this into a positive exponent. It didn't want us to actually expand. So 7 to the negative 6, we become 1 over 7 to the 6th. Okay, we want to simplify this here. This looks like 1,900,999. Yep, 1,999,999. What a big number there. All right, so this would be pretty darn crazy if we had to do any exponent work with it, right? But let's look at what our exponent is here. It's 0, right? So regardless of how big our base is, we should think back to our zero exponent property. The zero exponent property tells us whenever you raise a base to the power of 0, the result is going to be 1. So we look back here. We're raising a base to the power of 0. So that means you can forget all the other numbers here. We automatically know this is going to come out to 1. We don't even have to think about anything more than that. Whenever you see an exponent that is 0 and it's raising the base to a power of 0, then you just automatically know that you're going to get 1 as an answer. Okay, one last problem for us here. We want to evaluate 27 times x to the 0 times y to the negative 2 for x is equal to 4 and y is equal to 3. Okay, so before we do any work here for plugging in our numbers, I want to first just evaluate this a little bit. So let's simplify. We have 27 times x to the 0 times y to the negative 2. All right, well, first thing here, we have this x to the 0, right? We have this x to the 0. Well, what can we tell? Well, that's an integer or a base that is being raised to the power of 0, right? So we could just replace that with a 1. Right? Because it's anything being raised to the power of 0 can be replaced with a 1. Next thing we have is this y to the negative 2 right here. Well, that to me looks like our negative exponent rule there. So whenever we have a negative exponent, we can rewrite it as a fraction where our base and the exponent is in the denominator. So you can write this two ways, right? You could either write it as 27 times 1 times 1 over y to the second, or if we think about this for a second, when we multiply this together, again, this is going to be 27 times 1 over 1 times 1 over y squared. This would just become 27 over y squared. So yes, you can go straight to putting this in the denominator here. You don't have to take this intermediate step right here where you write it as 1 over y squared. Okay, now we don't really have to worry about the x is equal to 4 because we don't have any x anymore. It got replaced by a 1. We do have to worry about the y is equal to 3 though. So now I'm going to rewrite this, except instead of y, I'm going to replace it with 3. So instead of y squared, I now have 3 squared. Well, 3 squared is 9, and 27 divided by 9 is 3. So we get 3 as our answer here. All right, and again, we started off here by just simplifying our equation. We knew that x to the 0 would be equal to 1, so we replaced x to the 0 with 1. We knew y to the negative 2 would become a 1 over y squared, so we replaced it with that. Then we simply plugged in 3 for y. We had 27 over y squared. That became 27 over 3 squared, or 27 over 9, which is simply equal to 3. Alrighty, peeps, that is it for us today. So make sure you write yourselves a 2-sentence conclusion. Today we learned about 2 more integer exponent properties, the 0 power property and the negative exponent property. Alrighty, everybody, hope this video was helpful to you. I will see you all in class tomorrow. Peace out, y'all.